Thanks for the introduction. As was said, I'm Mark O'Hara. I'm the Senior Big Data Architect with Bluemetrix. So I've been working at Bluemetrix for the last, it's coming up on about 5 years now. So that's been purely in the big data space, working with a lot of big names and customers. And so in terms of who we are as a company, we are a big data company. So we've been working with Hadoop since about 2009, and we've worked with, I think at this point, it's probably closer to about 400 implementations. We have a lot of experienced guys that have been working with the technologies from, the very beginning. So, through all that time working with customers, we've seen a lot of things come up over and over again, and in particular, what I'll talk to you about today was kind of born of what we had seen out in the field, and how we could try and make some improvements there, and really help customers get the benefit of their platforms. So we have a couple of partnerships that are worth mentioning, specifically with IBM, obviously in terms of IWS, but we're also working as well on the Egeria open source project, which is a governance platform. And we also have a partnership with Cloudera, previously Hortonworks, before they had merged. So we have a good relationship with them, and we have a lot of experience working with their products in particular. So as I had mentioned, the application that we have developed in Bluemetrix is really born of what we've experienced and what we've seen customers struggling with out in the field. So we've come up with our Bluemetrix Data Manager, or BDM for short. And as you can see, really what we're trying to do is automate as much as possible for guys that are creating these data pipelines to ingest data, to get insights out of them, and then give management better overview of what's happening within the clusters. Because one of the things we've seen is especially when it comes to something like scheduling, there's a big disconnect between traditional software, such as enterprise schedulers, and then open source Hadoop software, such as, Uzi was kind of a popular early scheduling tool for Hadoop jobs, and so we're trying to also bridge that gap. The tools that are used within Hadoop, so some customers are still using them, but they're not without their problems. Using an enterprise scheduling tool such as IWS, it really takes away a lot of that pain in managing those things, and gives you the ability to just schedule and be confident that it's going to work. So there's a lot of stuff that we automate that includes, not only from a scheduling perspective, but also from things like a data governance perspective. So that means that anything that you do within our BDM tool, it's automatically logged to a governance platform, so that you can see the lineage, you can see what's happened between the time between data ingestion and then maybe your insights outputs to dashboards and things like that, which is really important from a compliance perspective in a lot of cases. We also try and automate things and simplify things for the developers of these pipelines by automatically validating data for them, so that you can see how much has been processed within a certain batch job, for example, and also giving you the insights into how things have run throughout the working day or throughout the week. With traditional tools for scheduling on Hadoop, you would find that it's very difficult to go into the logs and find out exactly what happened. Did it run successfully on time? Did it fail? Why did it fail? That was actually quite a big problem in the beginning, and we've really tried to simplify that as well within BDM. So we offer a lot of functionality within our application, and as I said, we also try and simplify it as much as possible. So later on, I'll show you what the tool looks like. But basically, you're now going from coding your big data jobs to creating them through an interface. Kind of a drag and drop interface to simplify things and really handle everything else in the background, such as governance for you, code management as well, things like that. And that's right through. So right through from ingestion to output, and then it includes like transformation, anonymization by default. We have scheduling, obviously, which is very important. And also from a compliance perspective, that the governance is really important, as I mentioned previously. So with GDPR and BCBS 239. So the one thing that comparing our tool to a native job type on AWS, the closest at the moment is probably a Spark job, for the simple reason that our application runs on Spark. So really what we're doing is we're not removing any. Sorry, so from a job perspective on AWS, it's like for like. It's a single Spark job represents a single Spark pipeline, right? And within our application, you're creating essentially that code, that Spark code that's going to run. And we use AWS to not only kick off the jobs and the pipelines when they should be, but also to pass information back to our application, the important type of information such as status, logs, runtime, all of that stuff, so that big data users can access that information without ever having to go to AWS. They don't necessarily need to have access to AWS. They can concentrate just within this application for getting all the information that they need and to develop those pipelines. So as mentioned, from data ingestion right through to the destination, we log every single action into our governance platform, and that can be validations, masking, transformations, and obviously we can tie that in with the actual governance representation for the ingestion and the output. So being that we're running on Spark, we're able to connect to databases or file systems directly and pull that data in a parallelized fashion, which helps speed up processing times. In terms of architecture, obviously this is a Spark cluster, and where AWS fits in, essentially for every instance of BDM, you would have what's referred to as an edge node, and the agent application would sit on that edge node with BDM so that they can work together. As I mentioned, if you look at creating these types of pipelines today without a tool like BDM, there's a lot of challenges involved in that. It can be, from the data side, it's very, very difficult to create these pipelines quickly. It takes a long time. There's code reviews, there's a lot of approvals that need to be gone through. It takes a long time even just to write that code before it's ready to run on production. And then once you do want to run it on production, you have to pass all of these parameters along. So in the case of a Spark job on AWS, you would need to pass along, yeah, there's a certain number of executors that are needed. There's a certain number of memory required for each particular application to run. They differ from pipeline to pipeline. And over time, as your data input increases, those can change. So you have to manage that within AWS jobs. And you have to configure that directly within the job itself. With BDM, we actually do that inside of our own application. So from the AWS side, we're really talking about a single instance of a job. The only variable in there is essentially pointing to a different configuration file depending on the pipeline that you're executing. So all of that tweaking for memory size and the number of executors, that all gets moved over to the BDM side, so that can be done directly by the data team. Another big problem was the feedback, as I mentioned. The going through logs was particularly difficult because they can be spread across multiple nodes, and it wasn't always easy to get those logs back from AWS, and that could just be people have other tasks to do. Providing logs, it's a very simple task, but if you need to do it 10, 20 times in a day, that can build up over time. And really, there's a lot of manual process involved in all of this and creating these data pipelines. So then from the AWS perspective, as I mentioned, there's kind of, because things can change over time, you can have more job failures over time. The resources that you provide may not be large enough, and you have to adjust that as you go. And that requires obviously communication between the two teams, and that just eats up time and resources, really. There's also the problem from the AWS side of knowing why a pipeline failed. Sometimes it can be to do with the contents of or sometimes you can gain more insight from looking at the actual data output rather than the logs. So it's important to have both of those when you're troubleshooting an issue like that. So if we look at how pipelines are created today, really there's kind of an even split between what teams need to do to get stuff running on production. So from the data side, they need to write the application, submit it for production, and that then needs to be created in AWS as a job. A schedule needs to be created, and then it has to be run. And if that works, it's great. You get the results that you're looking for, the insights that you want. But if it fails, it takes time to dig into the reasons of why it failed and how you can fix that. With BDM, the new approach is, as much as possible is done by the data side. They have full control over, what their application is doing in terms of the resources on the Hadoop cluster. Anything outside of the Hadoop realm is really just an approval from the AWS side. So when you deploy a job on BDM, you can create the schedule to go into AWS exactly as you want it, and all that's needed from that side is just an approval to say, yeah, that's okay, we'll let that run in production. Everything else is done on the side of the data team. And obviously that comes with a lot of benefits. From the data ops perspective, it just makes things a lot easier. It makes things quicker. You can create very simple pipelines very quickly. There's no messing around with deploying jar files, changing class files. It's it's just a much simpler process. And they also get that visibility for failures, as well as just anything in general in terms of runtime. They can see over time how many records are being processed at a time very easily, and then how that increases the runtime each time. From the IWS side, it simplifies job management. BDM creates these jobs in a very structured manner, so it's you can have confidence in it. Really, the only variability there is the scheduling, which is then up to the approval of whoever's managing IWS. And there's no requirement to communicate any information back between the teams, and everything is already provided to data ops. They have everything that they need to troubleshoot any failures. And yeah, so again, from an IWS perspective, they have full control ultimately over what runs, but then data ops, they have the freedom to create these pipelines quickly and troubleshoot with all the information that they need. So I'm going to switch over and show you a quick demonstration of the integration that we've done. So this is the main dashboard of our tool, and you can see that we have a single pipeline here called pathology, and even straight away we can see that pipeline status succeeded from the last run. So that's great. What I'm going to do with this pipeline is I'm just going to edit it quickly, and I'll go to this schedule option, and just for demonstration purposes, I'm going to basically manually order this job stream to execute now, and then we'll come back to it to have a look at the log output, etc. So we can see that that's been the run request has been sent. If I switch over to the monitor job view, we can now see that we've started up that instance and it's in a running state. So again, we'll come back to this to have a look at the logs, both on the IWS side as well as the BDM side. So I'll create a second pipeline here just to give you an idea of how easy this is. So we can select different data sources. It's very easy to configure these. We can add transformations as we need. So I'll just select an external table. So this is from a database that resides outside of the cluster. It's been added to BDM with a particular user and particular access to certain tables. So that's our data source, and then we have the option to perform any number of transformations or validations, masking, tokenization. We have the ability to do quite a lot with this, and it's very easy to configure. It's a simple matter of I'll just add a simple transformation here. So it's as simple as selecting it. As you can see, based on our data source, we can actually show you the columns that are in that data source. So you can choose what column that you're transforming. There's no risk of mistyping it. You don't need to reference anything. It's all pulled in to BDM and presented to you. So that reduces, any errors. So then we'll just create a test column output. And add the transformation. So it's as simple as that. You can add as many or as little transformations as you like, and then you can write it out to any destination. And so sometimes what we see is kind of multiple levels of pipelines where, given that we're running on a Hadoop cluster, a lot of the times customers will want to ingest data on a regular basis, like let's say a daily or weekly basis, to archive that data. And then with that archive, they can run their analytics over it, again, in a separate pipeline to then create your insights. So it's not uncommon to see just a basic ingest and then output onto a Hive. So Hive is just the SQL store on Hadoop. And we can set that. So very, very easy to create a pipeline. It can get very complicated if that's what you're looking to do. But in terms of going from writing code to this, it's a big change, and it really simplifies things. It's for simple pipelines like this, it reduces that workload for data engineers, so they're able to concentrate on more difficult problems, and someone with less experience can very easily create these types of pipelines. So then we come to the scheduling. So we have a couple of different options, and what we really tried to do here is pull in, well, not pull in, but essentially mimic what you would get from an AWS perspective, so that anyone that is familiar with AWS, it makes sense to them. But equally, because it's essentially a one-to-one mapping, if there is a need to troubleshoot anything there, it's very easy to do. So for example, if I want a pipeline to run, let's say weekly, we can say we want it to run every Monday, and no time zone, we'll use the default. And then the specific start time. So we can set a specific start time of, let's say, 9 a.m. And if we want to have a deadline time, so we can set a deadline time of, let's say, 12 a.m. Repeat. So if we wanted to repeat every 60 minutes until 12 a.m. Sorry, 12 p.m. And then we also have the ability to loop in dependencies. So as you saw, we started up that pathology pipeline, and we're able to pull that straight in and select that as a dependency. And we can say, if it's failed, or if we have a dependency failure, then we can, so that's our dependency. So what I'll do is I'll schedule this pipeline now. Just have a look. I'll just refresh the page and fill that in again quickly. So again, schedule run, might just give it a slightly simpler schedule. So specified time, say 9 a.m. Repeat every 60 minutes until 12 p.m. And we'll add our dependency again. So pathology failed. Okay, I'll go even simpler than that. It seems we've encountered a bug. But I just want to show you how it maps over to AWS at the back end. So I'll just give it a very, very simple schedule. Okay, so it's deployed this one here. Okay, so then if we go over to our Workload Designer, we can open up. So what we do, refresh that. Yeah, okay. So we store pipelines just in a simple BDM folder, and then for every single user that's using the application, they have their own folder where their pipelines are deployed. And as you can see, we simply use the pipeline name, but we also have an ID there just in case there's any duplicate names between users or between the same user. So for each pipeline, we create a job definition and a job stream definition. Session expired. Apologies for this. Just have a look. Very slow today. Okay, so if we take a look again at the demo 3 pipeline that we deployed, and the job stream definition, just view it. So we can see that we have a run cycle. So the run cycle, if we have a look, again, I just used that very simple schedule to have it run daily at 9 a.m. and then have the deadline time at the end of day. And then the job itself is very simple. It's as I mentioned earlier on in the presentation, it's the variables here are minimal. It's not actually visible here, but it's essentially just passing in a slightly different parameter that points to the configuration file for that particular pipeline. And then dependencies would also appear here, which I wasn't able to get deployed. Yeah, so then if we have a look back at our running job that we started off a while ago, so we can now see that that's come back as successful. I'll just open up the logs here. I'll open up the logs on BDM. So we can still see that this had a status of succeeded. We can now see that the demo 3 pipeline has been deployed. If we click on this status, it'll bring us to this page here. So here's our output logs for BDM alongside the output log for IWS. So once the job is finished, whether it's a success or a failure, it pulls that information right back in. So it makes all of that available to the user for any troubleshooting that might be necessary. Also with this, as I mentioned, there's a lot of governance. So everything that we had done along the way, now granted, this is again a very simple pipeline, and it's just an input and an output. But if we take a look at the governance platform, we can actually see that translates over to a lineage diagram here. So we can see we have an input from a JDBC connector that results in a JDBC data set. There's some built-in validations there. So these validations, they get written to a specific data set for validations within Hive, but also then the direct import to the pathology table in Hive is displayed there as well. So that's all automatically captured from the job that we just ran. So that more or less brings me to the end of the demonstration. So if anyone has any questions or feedback in general, I'd love to hear it.
What were the integration timescales for integrating BDM with IWS?
As in how long it took us to actually integrate?
Yes.
So I actually did all of the integration work myself. So it probably took me about, I would say, a total of 2 months, including just trying to get up to speed with IWS as well, because I didn't really have any knowledge of it beforehand. So I would say in and around 2 months. It's also important to mention that this is kind of an early version of it. There's a lot of stuff that we would like to add, and that we have added to other scheduling options. So that would be just rerunning of failed jobs in the plan view. There's other things when you deploy. So for example, when you deploy an update to a schedule or a job stream, usually end users would expect that to happen instantaneously, but it's always kind of lagging behind because you need to have your new day process where everything is loaded up for the next day. But we have automated that in another scheduling tool so that when a user makes a change in BDM, it can automatically be updated in the scheduling tool, right? So it's almost instantaneous from that perspective.
Right, okay. And in terms of the integration with the REST API, what language have you used between the two? Is it Python?
Yeah, so we're using Python to just directly call the REST API. Yeah. And so BDM itself is a mostly Python application with some Java specific modules. Yeah.
Okay, so your starting point was the Python examples from GitHub.
Yeah, exactly. So starting with that, basically taking a look at the included, so the page where you can send sample requests to IWS. I can't remember the name for it, but having a look at that to see the structure of messages, and then using the example on GitHub just to get the very basics going, so I can start sending requests and seeing what works and what doesn't.
Okay, so using the Swagger UI.
Yeah, the Swagger UI, that's right. Yeah.
Okay. The other question I had was, we heard from Emanuela this morning about integration with Azure Data Lake. Is that something that is of interest to you, and potentially other integrations with? Yeah,
absolutely. So when we talk about data sources and data destinations, if you can access it via Spark, then we can very quickly turn around a connector for BDM. Like if the ability within Spark already exists, which in a lot of cases it does. So for things like Azure Data Lake or Snowflake or just AWS S3, anything like that, we can create a connector for that. So it doesn't matter where your data is coming from or where it's going to. It's very flexible in that regard.
Okay, so potentially using future integrations within your pipelines is something that would be pretty useful.
Yeah.
Okay,
absolutely.
So Manuela, is that something you can connect with Mark about?
I would love to.
That'd be
So
great.
Mark,
Yeah.
we should definitely have a chat about it. I really like that.
I'd love to. Yeah. So does anyone else have any other questions? Particularly if you want me to explain something, if maybe I glossed over something a little bit. I just saw one come there on the chat. How would you apply change management controls? How would you apply change management controls requirements? So we use Git to detect changes between graphs, essentially. So if you were to add a particular transformation or modify the output in some way, we commit that back to a Git server, and then we're able to show over time how a pipeline has changed, for example. So you would be able to see what's been added, what's been taken away. So we have a customer at the moment that's going to be utilizing that. So they just use a standalone Git server. Yeah. Does that answer your question, Chris?
I think. Thanks, Mark, for the presentation. I think, yeah, that does answer part of it. I think a lot of our companies, and a lot of the guests on here, their change management control overall in terms of how their batch scheduling is controlled and when those amendments can be made and pushed through. How would you prevent some activity occurring in here that would then influence IWS? Because my immediate alarm bell for me would be the auditor saying, well, where's the change control there? Who authorized that additional activity and that new activity?
So I mean, in terms of, well, I touched on it in the presentation, when a change is made and deployed to IWS, that can require the approval then of somebody within IWS to say yes or no. And a very basic way of doing that is just if we can apply a rule in our application to state that any changes that have been made, it causes a redeployment to IWS of a draft job stream and a draft job. And then separately, we can also raise a ticket, for example, using a REST API to a ticketing system, or we can raise an email to a mailing list to then say that this pipeline has changed. We can also show what has been changed. And then that would prompt somebody to take a look at it and kind of approve it or deny it at that point.
Okay, thank you very much.
Mark, can I just follow on that point? Sorry, Liam here from Bluemetrix. Chris, there also is another layer of control around that we built into the self-service. There's a self-service option in the tool where basically business users and data owners can access pipelines that are working off templates, and these can be run through a set of controls where before any change is made on them or before they're run, that they're signed off by either the scheduling people or the data owners or the data stewards.